All right, welcome to the Explainer. Today we're going to demystify a field that is completely changing the game, AI engineering. Let's break down the blueprint for creating the kind of AI applications that are shaping our world.
So what's all the buzz about? Why is everyone talking about this? Well, for starters, the demand is just off the charts. We're talking about a field that's growing so fast that top salaries are pushing past $300,000 a year. Yeah, you heard that right.
Okay, so a massive paycheck is one thing, but that begs the real question, right? What does an AI engineer actually do day to day? Let's peel back the layers and walk through their entire process, from just a spark of an idea all the way to a real product you can use.
So first things first, we need to define our terms. What is AI engineering really? And maybe more importantly, why is it so different from the traditional machine learning we've been hearing about for the last decade?
Okay, here's the core idea, the big shift. AI engineering is all about building applications on top of these incredibly powerful, pre-existing foundation models. The game has totally changed. You're not spending years and millions trying to build a massive AI from the ground up anymore. Nope. Instead, engineers are leveraging these gigantic systems that companies like Google and OpenAI have already built.
And this right here, this is the fundamental shift I'm talking about. Think about it. Traditional ML, that was all about building from scratch. It required super deep, specialized expertise and was often stuck in this huge bottleneck of labeling data, which is just painful. But AI engineering, it's all about adapting these ready-made models. This totally lowers the barrier to entry, making it way more accessible for more people to get into the world of AI.
Okay, so if you're not building the model yourself, what's step one? Well, your first and maybe most critical decision as an AI engineer is picking the right foundation to build on. This single choice is going to shape everything that comes after.
And this quote just nails the new mindset, doesn't it? The challenge isn't about developing the models anymore. It's about selecting the right one for your specific application. The job has shifted from being a model creator to being more of a model curator, an expert at finding the perfect tool for the job.
So when you're picking that tool, you basically have two main paths, and it all boils down to a classic trade-off. On one hand, you can use a commercial API from a company like OpenAI. It's super easy to get started, it scales like a dream. On the other hand, you can grab an open source model and host it yourself. Now that gives you total control and keeps your data private, but it's a lot more complex and you've got to manage all the infrastructure yourself. It's ease versus control.
All right, let's get into the nitty-gritty, the craft itself. You've picked your model, now what? How do you take this general-purpose AI and make it solve your very specific problem? This is where the real engineering magic happens.
First up, and probably the technique you've heard the most about, is prompt engineering. Honestly, the best way to think about this is like an art form. It's the art of writing incredibly specific, crystal-clear instructions for a super smart assistant who takes everything literally. You're not actually changing the AI's brain, you're just getting really good at asking the right questions to get the exact answer you're looking for.
Okay, next we have something called Retrieval Augmented Generation, or RAG for short. And this is an unbelievably powerful technique. Seriously, it's like giving the AI an open book test. And the book? It could be your company's private documents, your entire customer database, or even live data from the internet. It lets the model answer questions with information it was never ever trained on, which is a total game changer.
And that brings us to the third method, the heavy hitter, fine-tuning. This is the most intense approach. So, if prompt engineering is like giving directions, and RAG is an open book test, then fine-tuning is like sending your AI to a specialized PhD-level graduate program. You're actually retraining a part of it on a very niche dataset, literally adjusting its internal wiring. You're turning it from a jack-of-all-trades into a world-class expert on one specific thing.
All right, so you've picked your model, you've adapted it, you're feeling pretty good. But how do you actually know if it's any good? How do you make sure it's not just making stuff up, or worse, saying something harmful or unsafe? This is where evaluation comes in, and it's a huge deal.
And let me tell you, this is one of the hardest problems in all of AI right now. Think about it. If you ask an AI to write a sad song, there's no single correct answer, right? There are thousands of possibilities. So how on earth do you reliably test something so creative and subjective?
Well, the solution is kind of wild, but it's also incredibly effective. You use another AI to be the judge. That's right. You can basically hire a super advanced model like a GPT-4 to grade the homework of your AI application. It scores the output on quality, on correctness, on safety.
And what's crazy is that studies show these AI judges are remarkably good at it. Their scores line up really closely with what human experts would say, but they can do it in a fraction of the time and cost.
But, it's not a silver bullet. Of course not. These AI judges have their own weird quirks and biases. For instance, they sometimes have a self-bias, where they just prefer answers that sound like something they would have written. Or position bias. They might like the first answer they see more than the second. And they definitely have a verbosity bias. They often think longer answers are just inherently better. A great AI engineer knows about these traps and designs their tests to work around them.
Okay, we're at the final piece of the puzzle. This is where the rubber meets the road. Because look, an AI that's brilliant but is super slow or costs a fortune to run, that's not a product, that's a science fair project. So let's talk about how engineers make these things fast, cheap, and ready for the real world.
When you're running this stuff for real users in production, it all comes down to a balancing act between three things. First, latency. How fast does a user get their response? Nobody likes waiting. Second, cost. How much money does it cost you every time the AI generates an answer? And third, throughput. How many people can use your app at the same time before it breaks? You're constantly trying to make it faster and cheaper while serving more people. It's a tricky trade-off.
So to nail that balancing act, engineers have a whole toolkit of sophisticated tricks. A really common one is called quantization. The simple way to think about it is that you're making the model's brain a little less precise, but way more efficient. It's like compressing a giant, high-resolution image into a smaller file. You lose a tiny bit of detail, but it becomes so much faster and cheaper to run, and most of the time, users never even notice the difference. And that's just one of many optimization techniques they use.
And there you have it, the whole life cycle, the complete blueprint. You start by defining the problem you want to solve. Then you choose your foundation model. You adapt it, using prompts, or RAG, or fine-tuning. You test it relentlessly to make sure it's good and safe. And finally, you optimize it so it's fast and cheap enough for real people to use. That, right there, is the blueprint for building modern AI.
So we've just walked through the entire blueprint of modern AI engineering. You now know the core steps, the key decisions, and the tools of the trade. The path from idea to reality is clearer than it's ever been. So that leaves just one question. Now that you know the blueprint, what are you going to build?